substitute it. So left side is Laplace transform 8. So we substitute here Laplace transform the double pi here, and then the first pi here, and then the x is a small x of x equal Laplace transform 8. So because like the initial value is given, so I circle it this order 0 and simplify this equation. I get this equation. I factor out x of x, and then I get here is equal Laplace A, because we know the Laplace A equal like a over x. So we get the x of x, that's capital X equal A over x divided by this equation. And then finally, I get here, you know, the denominator have like a 3 factor. So we use the partial fraction. We have like 3 parts, A, B, C, D, A over x, B over x plus 4 plus C over x plus 2. And then simplify it, working out, and then we get here the x power term coefficient is a plus b plus c, and then the x term, the coefficient is 6a plus 2b plus 4c plus a multiply a equal 8. As we know, here left hand side is known as power term, so a plus b plus c equals 0. Same thing like the x term is 6a plus 2b plus 4z equals 0. But a equal a. Over here, we get the answer a equal like a 1. So come back to the equation 1, we get b plus c equal -1. And then plus in the second one, we get b, simplify, we get b plus 2c equal -3. So we solve equation 1 minus equation 2, we get the c equal -2. And then plug in back to 1, we get the b equal 1. Plug in all a, b, c, d back to the x capital or capital X of x, a, b, c, d, and then we get the equation is 1 over x plus 1 over x plus 4 minus 2 over x plus 2. We need to solve the we need to get the x, small x of t, we suppose, and then the like inverse, like a Laplace transform, like a capital X of s. We use the linear Laplace transform. We get here inverse 1 over x, inverse this part, inverse this part. The final answer is t plus e negative 4t minus 2 e negative 2t. That's final answer.
Okay, great. Okay, Katerina.
Okay, give me a second, please.
Okay, sure.
Let me know when you can see it, please.
Yes.
Okay, so I have this question. It's from lecture 20. It looks something similar to question 1. So I have find Laplace of t to the power of 4 and e to the power of -9t. If we look down where it's highlighted in blue, we have this formula e to the power of 8t times t to the power of n just turns to n factorial over, in parentheses, s minus 1 to the power of n plus 1. So in this case, we have n equals to 4 since t is to the power of 4, and a equals to -9 since e is to the power of -9t. And then I just plug in what's in the formula. So since our n is 4, it will be 4 factorial over s minus -9 to the power of 4 plus 1. And then we just simplify it a little, and then we get 4 factorial over s plus 9 to the power of 5. And then 4 factorial is just 4 times 3 times 2 times 1, which gives us 24 over s plus 9 to the power of 5.
Okay.
Thank you.
Thank you. Anyone else like to present? Especially for those people haven't been presenting, you need to show me how much you understand. Are you able to catch up with the rest of the class? Let's see. Gregory, you haven't been presenting. Oh, you have presented the last class, right? Kyle, Francis, Liz, Marquise, Rosa, Ryan, Suzanne. I really need you guys to present. And I was thinking about talking about 20, but I'm also thinking maybe I just stop because we don't really have much left. Let's go to ours. So I have day 20. Right? We only have 3 classes material. And yeah, Katarina talked about a little bit about 20 already, and also Yinping used the formulas in 20 already. But somehow I don't feel go further before seeing the rest of you presenting and show me you have Laplace transformation and the inverse transformation under your belt. Because the meat of this class is, or the crown of this class, okay, is Laplace transformation. So after 20, we have 21 and 22. The convolution theorem, derivatives and integrals of transformations. And then the last bit is to deal with piecewise continuous functions. So this one is not much, okay. All right, can we do this? Should I show you your grades? Not grades, your only presentation. Let's only see the presentation part. The presentation, okay, Katerina, I haven't given Katerina credits yet. Let me give her credits. Katerina, right here. Okay, so basically your presentation gives you at least 30%, not at least 30%, right? 30% of your grades. And but it doesn't mean like it's like this. You see, let's see Ryan, right? Ryan has presented 10 times, and Ryan's question, the question he chose are pretty good. So that shows his level of understanding mathematics. But lately, Ryan was too busy with other classes, and so Ryan hasn't shown me how much, understanding of Laplace transformation yet. So I don't think Laplace transformation is difficult. And also, even before Laplace transformation, right? Frobenius method, even before Frobenius method. So those guys are like the core of this course. So I really need everyone to show me your understanding. And the final exam will be heavily on the second part, because the previous chapter is just preparing us for this core part. So the exam will be given over this kind of material, right? So I think the presentation is also to prepare yourself, right, to take in the final. And the presentation gives you 30% of your grades, because I don't want you to put everything in one basket. So the final grades, how much? Let's go to our syllabus. So also presentation, you have to choose, as I mentioned in the very beginning of the class, you don't want to present the baby questions all the time, right? If you do that, that means, that shows me you only can master those babies. Right? If you want to show me you deserve an A, right, you need to show me some decent questions you are able to go through. So let's see. Oh, I didn't give you grading policy, did I?
It's in the announcement.
Oh, I see. I didn't, right. Thank you, Anchi. Oh, right here. Thank you. You know, in the middle of semester, I'm so tired. I'm teaching 4 courses. Anyway, you guys are the best. You know, I'm teaching 2 courses of college algebra. You know, I spend so much time for those kids, because I thought they were like aliens. They do not understand mathematics at all. But then they have their argument. They said, you know, 3 years of COVID, because they just came to college, first year freshman students. 3 years of high school, we learned nothing. So, you know, so right away they gave my passion. So what I did is I spent so much of my free time to put up YouTube videos for them, to try to make up the very basic stuff of mathematics for them. And fortunately, it did help some of them. It did help some of them. So I didn't really spend too much time for you guys, because I know you guys, you know, this is an advanced course. So I put up all the notes, all the assignments there. And you know, what is college all about in the end? First, to get your degree. I think the most important part is to teach you, is to shape you, is to help you to be a self-learner in life. I think that's the big part of going in higher education. It's not about the stuff you have learned in it, because maybe you only use 20% or 30% of the knowledge you learn in college. But through the 4 years of college, if you go to graduate, go to PhD, there are more years. Through all those years, your brain, you know, the human brain will be shaped and will be sharpened into some very, you know, into a very fine machine to solve life problems. I think that's a big part of education. Oh, what's going on? Am I talking to myself?
No, we can hear you.
We can hear you.
Oh, okay. Israel, what's going on? I saw Israel, pardon me, has the presentation stopped. Israel, are you planning to present? Oh, okay. I didn't see you typing any numbers. because Katerina was the last one. If you want to present any questions, it's your turn. Okay, you set up. I'll keep talking. Anyway, right. I spend a lot of time for those kids. They're like babies, you know. Their complaint made sense. And actually, I thank them a lot because of them, they motivated me to finally go on YouTube to be a YouTuber. Because before I was so against all this kind of stuff. Okay, you go ahead, Israel. You cannot share. What do you mean?
Pardon me, I wasn't giving the presentation.
Oh yeah. You're right. You probably came in the middle.
Yeah, it just came right now.
But yeah.
There we go. So yeah. So what I'm going to present is a modified version of 19.3, where I changed it to what, x double prime plus 3x prime minus 4x prime, and where we have the initial values of x.
Hold on a second. What is your equation? Do you have an equation to work with?
Yeah. It's x double prime plus 3x prime minus 4x.
That's it. That's an expression. That's not an equation.
Oh, equal to 0. Pardon me. I forgot to put equal to 0.
Oh.
Yeah, I kind of just been dropping the 0 by accident in my mind. Yeah, so with x not equal to 9 and x prime not equal to 2. So of course, you know, as the textbook suggested, we let capital X of s equal to the Laplacian of x of t, which gives us a very simple equation of x squared capital X of s minus s x naught minus x prime naught plus 3 s of x s minus x naught plus 4x of s, which is equal to 0. So of course, solving for all of this, it will bring us down all the way to x of s times s squared plus 3 of s minus 4 minus 9s minus 29, which is equal to 0. So as well, you know, continuously following what the book suggested, we then make this a, sorry, I'm trying to catch my breath a little. We then let x of s equal 9s plus 29 over s plus 4 times s minus 1, which is what the binomial, which is multiplying x of s, is equal to, which simplifies to. And then we do the, I forgot what this part was called. It's when we split it up. We split up the denominator and make it so.
Partial fractions.
Partial fractions. Thank you so much. We then use partial fractions to then solve for a equation which is in 2 parts. So what I got was from my modified equation was I got that my b was equal to 38 over 5, and my a is 7 over 5, as a plus b is equal to 9, and 29 is equal to 4b minus a. So then substituting that in, we get capital X of s is equal to 7/5 over 2 plus 4 plus 38 over 5 or 5.
2 plus 4. You don't recognize your own handwriting. 2 plus 4 won't make any sense.
I said 2 plus 4?
You said 2 plus 4. That's
Oh,
what I heard.
apologies. S plus 4. S plus 4. Oh my god. Sorry. So yeah, so 7 over 5 over s plus 4 and plus 38 over 5 over s minus 1. Now we then take the reverse Laplacian, which will make x of s
Inverse,
equal to x of t.
not reverse, inverse.
The inverse, pardon me again. The inverse Laplacian. And of course, we can take out any constant that's multiplied. So it would be 7/5 the inverse Laplacian of 1 over s plus 4 plus 38 over 5 of the inverse Laplacian of s minus 1. And of course, that just simplifies to 7/5 e to negative 4t, 38 over 5 e to the t. Sorry, I'm just very out of breath right now. Sorry. And that would be it, yeah.
Yeah, it seems like you're catching up with your life. Anyway, were you in my vector calculus class?
Multivariable?
Yeah.
Yeah, yes, I was.
Yeah. I didn't remember you were so busy. Maybe life gets busier now.
Yeah, especially with classes and all the other things that come with it.
I say you're graduating this year, so maybe most of you graduating, right? Okay.
I'm
let's
not.
see,
I'm graduating next year.
Oh, next year. I see. Okay, let's see. Suzanne. Yes, Suzanne wants to present something similar.
Yeah. Can you see it?
Yes.
Okay. So this is the function is right here. Is the x prime plus 9x equals to 1. We have f of 0 to 0 and x prime of 0 to 0. So I have to solve for the initial value method using Laplace transform and also using the inverse Laplace transform and apply partial function method to determine the coefficients. So right here, I'm going to use the Laplace transform to find it. So we have x of s equals to the Laplace of x of t. And I put in the function over here into that. That would be the 9x plus equals to 1. And solve for that. So that's
Hold on a second. I don't understand your notation. What do you mean x of s? Oh, no, this one. This one makes sense. This one makes sense. Right? That's what we want. What is the second line? What is the second line?
Oh, that's the function up here. I plugged that in.
Yeah.
I just put that in.
You cannot do this, right?
I should have removed this. Sorry. I should remove this s of x. I was just showing that that's what I was going to solve for.
Yeah. You're right. This part just doesn't make sense.
Yeah, you can cancel. You can. I cannot forget the s of x in the front of it. Yes. All right, my bad. Moving on. So here we know that Laplace of 1 is equals to 1s. So I'm going to use the Laplace transformation of derivative. And that'll give me s squared. And that will give me this equation right here. The s squared plus x of x minus s minus x of 0 minus x squared 0 plus 9x of s.
Not x squared. This
what?
is not x. This is not x squared, right?
Which one?
This one I highlight. Can you see my blue highlighting?
Sorry, give me a second.
You cannot see it.
No, it's not x squared. That's x prime of 0. Sorry about the handwriting.
That's right. Well, as long as you can recognize yourself, that's fine.
Okay. So for that, I have s squared of x of s plus 9x of s equals to 1 over s. and that eventually gives me 1 over s into x squared plus 9. So I want to now do this using the partial fraction method.
What
So
happens with the terms? Can you tell me why this term is gone?
which one?
Or you cannot.
It's right here. The 9 over s is down here.
No.
Equals 1s.
Okay. Right. The middle term s times x of 0 and x prime of 0. Why those two terms are gone?
Second. Are you talking about the middle part?
Yeah, you see, okay, you cannot see, because on my side, I can see I have blue highlighted, blue light, I put blue lines under those, but you cannot see them, right?
No.
You cannot see blue line. Okay, so let me read for you. So under your Laplace transforms of derivatives, under this sentence, right? Down below, you have x squared, x of s, minus x times x of 0, minus x prime of 0, plus 9x of s equals to 1 over s, right?
Yes.
Okay, so this one was simplified to be the next line. The next line, you only have x squared, x of s, plus 9x of s equals to 1 over s. So I'm asking how the other two terms gone, not in this anymore. Namely, s times x of 0 minus x prime of 0.
Yeah, I was solving that by the initial value, so that's why they're not there anymore.
You're not solving this, you're simplifying this. Okay,
Yeah, I'm
what about
simplifying it using the initial value. That's
okay,
why
what's the unique values?
the initial values of the given was right here. It's s squared x of s, and we have plus 9x of s equals to 1 over s.
Yeah, you're given the right reason, but why is that? What is the given initial value?
Sorry, I don't
Susan is
understand.
trying to help you. Susan is trying to help you, but you. Suzanne, I have to tell you,
What?
I cannot accept a presentation like this.
Oh.
This is the baby questions I'm asking you. You cannot even answer me. Okay, let me tell you what's the reason. Your given initial value is x of 0 is 0, x prime of 0 is 0. And you read it
Yes.
twice, x prime of 0 to be x squared of 0. So that gives
No,
me
it's
doubt.
not x squared.
Yeah, that gives me doubts. Who did this work? If you choose to keep going, I'm
No,
gonna
I
ask.
said it was x prime, not x square. It was the way I
Okay,
wrote it that looks weird.
okay, you can keep going, but it's just be prepared. I'm going to ask you more questions. All right.
Um, okay. So simplified all the way we have s of x equals to 1 over s x squared plus 9. And then I want to use the partial fraction method to solve that, which will give you a over s plus b of s plus c over s squared plus 9. So I'm going to multiply both sides by
Hold on.
s.
Hold on a second. Hold on a second. Let's go back a little bit.
Okay.
Okay, explain to me how did you get x of s equals to 1 over s times s squared plus 9?
Sorry, what part?
X of s. So how did you solve x of s?
Do you mean under the Laplace of derivatives?
1, 2, 3, the fourth line under Laplace.
Okay, give me a second. Also, the x of s is already in the equation, is right here on the third line where it says s squared plus 9. That's the s of s right there equals to 1 over s. So I'm just simplifying it. This s of 9 comes to the other side down here. It goes over to where 1 over s is. And that's why it's x of s equals to 1 over s of x s squared plus 9.
Okay, it's better to say x of s is the common factor of x squared and 9, so you factor it out. Then you divide it by x squared plus 9 on both sides. Okay, now explain to me partial fraction method. What did you do here?
Okay, on this side I am multiplying both sides by s into s squared plus 9 to both sides.
What do you mean by both sides? Okay, what is the partial fraction method?
I have the what's it called? A over s plus bs plus c over s squared plus 9.
Yeah, I know what you have. Can you just explain to me what is partial fraction method? Can you use English to explain the mathematics?
So that's they're trying to do the fraction expansion of the operation right here.
No, you're not doing expansion. Okay. What is the purpose? What is the purpose of applying partial fraction?
Is to rewrite the fraction in a more simplified manner.
More simplified. I would say this is more simplified. I would say the left hand side is more simplified. It's not in the simplified version. So okay. When we apply partial fraction, there's a purpose of doing that. Can you tell me what is the purpose to even do partial fraction?
So the reason why I'm doing partial fraction here is because it's part of the question was to apply the partial fraction method to determine the coefficients. So that's why I'm applying it here, to determine the coefficients of the equation of the function.
Determine the coefficients of a function. Which coefficient of which function?
So I want to determine the coefficients of the 1 over s equals into s squared plus 9 that I got here. So that's why I'm applying.
Okay, can you go even a little bit further to see, okay, why do you need, so okay, why do you have to change 1 over s times s squared plus 9? Why even bother to do something with it?
The only reason why I was changing it was because that was part of the question.
The question asks you to do partial fraction?
Yeah, I wrote it up here. It says part of the steps that it asks us to do. There's a pi plus is on the top. After solve by initial value method, the next thing was apply partial fraction method. And then it wanted us to solve using the inverse Laplace transform formula.
So this is in the question, tell you to do this, you're doing that only because the question asks you to do it?
No, it's to simplify and solve and get the answer at the end.
Yeah, I think those three listed above are the steps to help
Yeah, that's
you
the
solution. The question itself is not asking you to do partial fractions, but you're
no. The
doing
question
partial
itself is to find the initial value for the.
exactly. So my question is right. So your answer doesn't not answer my question. My question is asking you why you even bother to do partial fractions. You are saying because above I have this step, I have to do it. No, that's not what the answer is. What is the answer supposed to be? Why do you have to do partial fraction? For what purpose? What bothers you? You have to do this.
Okay, the reason why I had to do the partial fraction is to simplify this so I can get the values for A and B, so I can use it to find the initial
You
value.
you do not even have an ABC in the beginning. You only have 1 over s times s squared plus 9. So what is the problem with 1 over s times s squared plus 9? Why do you have to change its form?
There's no problem with it. I still use it in to find the inverse.
Okay, yes, your question is right. You're trying to find the answer. How does this partial fraction help you to get to your answer in the end?
I don't understand the answer you're looking for.
Okay, anyway, you can keep going.
Okay. So, what's I? So right here we have the, s squared plus 9 to a plus into s bs plus c equals to 1 to find the coefficient of the constant on both sides. So it would be 9a equals to 1.
Okay,
If I
can you
divide both
explain,
sides by 9.
can you explain to me each step, you know, one at a time? How did you do this partial fraction?
So here I'm multiply s into s squared plus 9 to both sides.
Okay.
And that gives me s squared plus 9. You have a plus into s bs plus c equals to 1 down here.
Can you tell me how did you get s squared plus 9 times a?
I multiplied s into s squared plus 9 on that side. So that's how I got that. The s cancels the s in the front of
Good.
it. So
That's what I want to listen. That's what I want to hear. Yes, the s gets cancelled. So you're left with a times x squared plus 9. Okay, great. Okay, keep going.
okay, and then the other coefficient, that'll be 9a equals to 1. I divide both sides by 9.
Can you tell me how did you get a 9a equals to 1?
One second. So the 9a equals to 1 is, I have the 1 over here. I was trying to get the coefficient of the constant. The constant here is the a. So we multiply the a by the 9. That's how I got the 9a. Because I'm trying to get what's called the coefficients for a.
Right. So on the left-hand side, you have 9a as constant. On the right-hand side, you have 1. So they have to match up because the equation,
Yeah.
that's the 9a equals 1. Okay, great.
And then I divide it by both sides by 9. The 9 cancels out on the a, and then we have a equals to 1/9.
Okay, now can you explain to me why b equals a -1/9?
One second. So is equals to negative because it's a bit the opposite of a, so that'll be negative. Since a equals to 1/9 is positive.
How do you know b is opposite of a?
Sorry, 1 second. So that's the coefficient of that's the coefficient of a, so that's why it goes to negative.
That's the coefficient of a.
No, I'm saying the coefficient of a is 1/9. So
Yeah,
to get
a
b
is
to be
not
the
fine.
negative.
That's very clear. A equals 1/9. You explained very clearly. Can you use the same method to explain why b equals -1/9?
Okay. So over here, if you're doing the same thing for b, 1 second. That'll be negative because the one on this side come over to this side. That would make it negative because the sign would change.
Which side comes to which side?
If we're moving from the sign changes when it moves across the equals to sign, so that's why b is a negative.
I do not understand what you're saying. Which move to which side?
I'm saying like if we move if we say a is on over here and is 1/9, and we move it across to the other side, becomes negative for b because it's an equals to sign, so the
You
sign changes.
remove which to which side? I do not understand.
The 1/9, which we know is for A, if it goes
Yeah.
across, it becomes negative. So that's why
What do you mean it goes across? It goes across to where?
the
A goes
the
across to. Is someone typing for you?
no,
What do you mean? I don't understand what you're saying. A go across to where?
I'm saying this equation right here.
Can you type in the
If we
chat?
plug in this, the one you circled,
Yeah. Oh, you can see
the
my
S,
circle. Okay. Oh, you
I
can
can
see
see
my
a
circle.
circle now. Yeah,
Okay.
I can see a big circle.
Okay. I'm gonna give you a hint to explain yourself. Let me change my color.
Sorry, 1 sec. Okay.
Okay. So how did you get B equals to -1/9 comes from this red color now, since you can see them. I thought you cannot see my.
Which one? Okay.
Can you see it? My red color. Okay, I'm gonna give you a hint. B equals to
Okay.
-1/9 because you explained very clearly why A equals to 1/9. So you get that one very right. You use the same reasoning to explain to me how you get B equals to -1/9. Okay.
Okay. Okay, so we're gonna refine the code. Sorry, give me a second. Let me write this down. So if I plug in 1/9 into right here to the big circle you made for A,
Mm-hmm.
that's 9, 1/9. Yes.
Let me
Yes.
substitute for you. Okay, actually, let me change it for you. So you substitute 1/9 here.
Yes.
Then what?
So then by times that by B to get the coefficient, I'll have 1/9B equals to
How
1.
do you get a 1/9b?
I multiplied the 1/9 by B.
How do you apply 1/9 by b? I do not understand what you.
1/9 plus B.
Can you? Okay, let me ask you. Can you write on your side? I can write on this. Can you write on it?
I cannot write. Let me see. 1 second. Let me see if I can write on my screen. I don't know if it will let me do that.
Suzanne, I want
1
to give you
second.
credit. Okay, all right. I want to give
Are
you
you?
credit, but you
If
need to
it's,
explain to me. For some basics, you cannot explain to me. So I'm.
sorry. 1 second. I'm trying to see if I can write on the screen. Oh, fuck, it's not working. Oh,
Oh, I saw you. I saw you were writing it. Cause I
okay.
don't understand what we are saying. Maybe your writing can make me understand you.
Yeah. So I'm trying to say 1/9 plus B.
Just read on the board.
Mm.
Okay, where do you get a 1/9 plus b?
The 1/9 is the 1/9 form that is right here that you helped me to write. Substitute that we got for A.
Okay.
So I solve for B.
So where did you get a 1/9 plus b?
I got the 1/9 plus b from solving for b from this right here, this long equation, the s squared plus 9 into 1/9 plus sb.
Which part? Right? Which part? Which part allows you to do that? So what makes you able to write 1/9 plus b or a plus b?
What? What part?
Okay, so you wrote here, right? 1/9 plus b. Where does this come from? You said come from this one. How and why? So from which one? So this equation, this longer one, long equation, how does this long equation allows you to write a plus b?
So I replacing a by its value, and to get the
I
constant,
understand
I
that.
want to
I
solve for
understand.
b.
Yeah. So let me change my question. So
Okay.
what makes you, right? So why you can have a plus b? What was the reason you can write a plus b?
That's because those are the. 1 second.
Do you understand that Ryan is trying to help you? Do you understand his notation?
Sorry, give me a second. Okay, he said as squared bs squared, yes. Yeah, so he's able to do that because of the equation, right? As squared plus bs squared. So s squared doesn't have any coefficient, so that's why it's a plus b equals 0. That's why I'm able to do a plus b.
Yeah, you're getting closer to that. Okay. So what's your coefficient on the left-hand side of s squared? You have this equation here, right? On the left-hand side, what's the coefficient of s squared?
It has the coefficient has no value, so it's just 0.
No, the coefficient, my question is, what is the coefficient of x squared on the left-hand side of this long equation? Let me make another color so you can see clearly. Now I'm going to make a green is not so obvious. Let me make a purple color. I'm talking about this longest equation, which you get an a equals 1/9 from. What's the coefficient of s squared on the left-hand side of this equation?
Coefficient would be a plus b.
Great. A plus B with a question mark? No, it's just A plus B, right? Okay,
Yeah.
now, what is the coefficient of S squared on the right-hand side of the equation?
B is 0.
0. Okay, that's what the line is writing for you. Because
Okay.
AS squared plus BS squared equals 0. So you factor out S squared. So A plus B is the coefficient of S squared, which equals 0. So if A plus B equals 0, what happens? What's the relationship between A and B?
So if we have A plus B equals to 0,
Mm-hmm.
yeah, and we already got A, so that's why we're able to substitute it into the A.
Okay, all right, great. Finally, we got it. Okay, now you have your A, you have a B, right? Now your fraction, you have your partial fractions now. Now you see this fraction is become two fractions, the subtraction of two fractions. Okay, now explain to us how you use this result.
Okay, so after this, I have to do the inverse Laplace, and I'm going to do that for both sides of that. So that's what you see up here, which is the Laplace inverse of 1/9s, and then I have it here as well. So I just
I'm going
we
to
brought out
I'm going to
what?
have a question right here. I'm going to ask you a question right here. When you apply Laplace, excuse me, you apply Laplace this way, Laplace inverse this way, right? Laplace inverse of everything, right? Of two terms. So what enables you to write your Laplace inverse function separately? You write 1 and 2. Can you tell me the property of Laplace enables you to do this?
Um, the linearity property.
Right? Okay. Now you can keep going.
Okay. So after that line using the linearity property for that, I have 1/9, the Laplace inverse of 1/s, minus 1/9 with the Laplace inverse into s/s squared plus 9. And then that gives me 1/9 minus 1/9 cos 3t.
You don't have
And then I
cos.
just
Oh, hold on. Hold on. Let me ask you a question. Okay. How did you get 1/9?
so 1/9 is right here up here. When we did the I don't know if you can see the first circle up there. Yes.
But
So
this above
we factored
1/9.
it out. Huh?
Your above 1/9 has Laplace inverse of 1/s. Where does
Yes,
this go?
I factored the 1/9 out, and that's how I got 1/9 there.
You factor 1/9. What do you mean? I don't understand. You factor where? This is not a factor. This is just 1/9 by itself.
Well, I have 1/9 by itself, so it comes down here.
So what's the value of this? The inverse Laplace of 1/s. Where did this term go?
The inverse of that is, sorry. That just gave me 0. That's why it's not there anymore.
If this is a 0, what's 0 times 1 over 9?
No.
If
So
this is 0, what's 0 times 1 over?
It's to be 1, and then 1 times that would be 1 over 9.
It should be 1. So
Yeah.
y is 1. What's the Laplace transform of 1?
The plus transform of 1 is t.
No,
Yeah, but 1 second.
really in front of you.
Wait, sorry, repeat that.
I said it's right in front of you.
The x equals into t.
No, Laplace transform of 1 is 1 over s. That's why your inverse Laplace of 1 over s is 1.
Oh, I don't know that's what you were
Times
asking.
1 is 1 over 9. All right, now can you explain this part?
What part?
The second one, I just circled.
So you have negative 1 over 9. It comes down here, and then I use the trig substitution to find. So that's why we have the trig substitution of Laplace inverse of s over s to s squared plus 9, and that's how we got cos 3t.
Okay, so what is the Laplace transformation of cos 3t? My question is, what is the Laplace transform of cosine 3t?
It's s over s squared plus 9.
Okay, great. All right. Okay, keep going.
Okay. So wait, what's that? So that's how I got 1 over 9 minus 1 over 9 cos 3t here. And we're trying to find the initial value of that. So that'll be x to t equals 1 over 9, 1 minus cos 3t. I factor, I factor the 1 over 9 out, so that's why we have the 1 over 9 here. And then it's be 1 minus cos 3t. And that gives us the initial value for the equation. And that's what I wrote here. So, and that's the answer.
So this solution is the solution to this equation with the given initial values of both x of 0 and x prime of 0 to be 0. All right?
Yes.
Okay. All right. Thank you. Thank you. Okay. Anyone else like to present? Okay. Anyone else like to present? You know, when I have doubts, when I want to make sure you understand, I start to ask questions. You know, I start asking, depending on the level. If you cannot answer the difficult questions, I'm lower the level. If you cannot answer the the middle level, I ask in the lower level, I keep going down, because this way I can understand how much you're catching up with the material. Anyway, we still have time. You know, we still have a couple of weeks, right? How much time we have to the final? Final is on December 14th. We have exactly 1 month. All right. If you have been working hard, keep working hard for the rest of this month. Oh, what I was talking about? I was talking about our grading policy. Okay, 10% attendance, 20% homework. I think most people have no problem with homework. 30% presentation, then 40% of final, right? So 10%, 20%. So let's go to the grade center. So presentation is 30%. Let's see this. So this shows everyone's. I hope you don't mind. So starting from Liz, Gregory, Christian, Jean E, CeeLo. I have no idea who. Sometimes I see him in the class. Are you here? But I don't think he's here today. Ronald was saying you were going to present today. Yaprak. But Yaprak, your problem is you always show the baby questions. You need to show me, if you want to get high grade, better grade, you need to show some decent, you can do some decent questions. You can present some, questions with a certain level of difficulty. Hold on a second. Is it Yaprak or Katerina? I don't remember, one of you. Let me see who's presented more times. While Israel is catching up, Israel's life is so busy. Shu Xian, Moses, so a couple of you are doing great in class. You're leading this class. But Moses started late. That's why you only have 90. Bi Xin is my old student. Yeah, Bi Xin is my old student. Some of you are from my multivariable calculus or vector calculus rather. Bi Xin, are you here? Oh, David.
Yeah, for final, are we allowed to bring a sheet of paper?
You think you need? If you think you need, yes.
All right, cool. Yeah, I think for, like some stuff, I don't know, it's just a lot to memorize. Like there's like a lot of, especially just like the few times we have to use trig, I think.
Yeah.
That shows up, so.
Yeah, okay, I will allow that. Right, you can put the theorems stuff there. Okay, that's fine.
Okay, because I like remember like the concepts and stuff. It's just like some of the specific equations I forget.
Exactly, I understand. Yes.
All right, great.
Shen, Leverson, Ryan just haven't been presenting lately. Kyle presented once. Yinping. Suzanne is catching up. Okay, Suzanne presented today also. David, Katerina. Oh, I think it's Katerina, right? It's not Yaprak. Yaprak pick good questions. Katerina, you need to pick some more interesting questions. Okay. Albert was doing great, but you need to do more. Marquise, never done anything yet. – Rosa, I haven't heard from you yet. And Zihao, I haven't heard from you yet. So how are you going to? So if you haven't been presenting, right, you're basically putting all your eggs in the final, which is very dangerous. So we still have time. We still have about a month, except holidays, to catch up. And last class, I think someone, maybe Albert, asked me if you can present twice in class. I said, as long as you choose different type of questions from different sections. All right, and it has to be interesting because we're towards the end of this semester. Yes, David.
What is your grading policy towards like an A? Like, do you have an A minus? Is like 93 and up an A? Is there an A?
Yeah, we have A plus, A minus. A plus is 90 above, 98 and above. And then we have A is from 92 to 98. And then we have A minus 90 to 92. Then B plus, B, so on and so forth.
Okay, yeah. Because I know sometimes like to get an A, sometimes you need a 94 and up, sometimes it's 93, like it's different.
To get an A is from 92, I think. 92 and above.
Okay, that's good. Thank you.
You're welcome. Okay, so yeah, I see Ronald is here. Ronald, did you tell me you were going to present this class? I see Marquise here. Yeah, Ronald.
Yes, I was trying to present something from the last number you had, but I'm not sure if I can share. I'm gonna try.
You want to present now? I have to make you a presenter first. Okay. Try it. What hurts to try? And Rosa, I haven't heard from you. And Marquise, I haven't heard from you. Kyle, you did it once. You stopped it. And Gregory was doing great at the beginning of this class. I think it's very easy to get A or even A plus in my class. Life happens. I understand, Yeah, I understand that, Gregory. It's okay. It's okay. Yeah. Anything happens is not end of the world. I understand. Surely okay. So Ronald, you can present once you're ready. You are a presenter now. Rhonda having some internet problem, maybe. Kyle, Marquise, Rosa. Are you guys betting on the final? I'm telling you, final is more difficult than presentation. Two people are trying to reconnect. Let's just wait a little bit.
Professor, do you know how many questions are going to be on the final?
About 10 questions,
Okay.
normally.
Okay, got it. Thanks.
Okay. Or sometimes I do this. Sometimes I give more questions. Maybe I give 12 or 13. Then out of this 13 or 12, you choose 10 of them.
I got it. Can we bring a calculator or no?
Yes.
Okay.
Yes, if you need a calculator, it depends on what kind of calculator.
Okay, thank you.
It just cannot be this fancy calculator is, does all the job for you.
Yeah, I get it.
Maybe a scientific calculator help you to calculate numbers, but we don't really need to calculate numbers. It's all algebra. Yeah.
Yeah, that's true.
Yeah, you don't really need a calculator, in my opinion. Let's see. Obviously.
Okay, thanks.
You're welcome. Okay, Ronald, I was thinking you have some issues, but you are back. Let me read your comments. Aubrey saying he never had an in-person final for an online class. Can we do it online? No. Yeah, they have to reschedule the time. Every final, doesn't matter if it's online or not online, every final is supposed to be on campus. David is saying, can we do that one? That it will be good. Choose a question. Yes. So if you like more questions, giving you maybe like 12 questions. So out of 12, you may choose 10. 8:30 to 10:30 is pretty late. It's late for you. It's late for me. So I wrote. So today I wrote him again to remind him I need to change this time during the maybe afternoon. This is too late. Let's see. Because reschedule is not easy. It has to go through the school administration. It's not departmental case. It's a campus case. What if they reschedule the final to a time when we already have a final? That's right. That's right. That's why they have to consider. That's why rescheduling is not an easy case. So they have to consider other math courses won't have this conflict. So I don't know. He hasn't replied me yet. I also asked him, if we cannot do that, if it's possible to do online. I also asked that too. Yeah. 8:30 to 10:30 is really, really late. Okay, Ronald, we're waiting for you once you're ready. Oh, you only have about 15 minutes. Kyle is saying something. Hold on, Kyle. Yes, you have traveled home to Bronx. Okay. Let's see. We will see.
Am I presenter right now, or just
You are a presenter. You can share your screen. Do you know how to share your screen? You go to share content on the bottom. Okay. You click on share content. Then you choose the second option. The first option gives you blank whiteboard to write on. But you want to share application /screen. You want to share your screen with us. So you choose the second one. But first you have to open your file.
Yeah.
Okay.
Where is that one?
I think he has some problem. Okay, anyone has any other questions? While we're waiting for him, let's also see. So presentation, attendance, homework. Rana, what's going on?
I had to click on my Windows because it was acting up. It just keep fuzzing out. I don't know.
So your internet is not so good?
Yeah, it's not allowing me to do it. It keeps freezing out.
Oh.
Yeah.
Are you using a computer?
Chromebook. Probably that.
Okay. Yeah, it's up.
Okay. Let's see. Can you see that screen?
Yeah.
That's
I love.
the harmonic possibility is number 12. It's a very simple question asking to find the inverse of
Oh
most.
no, we don't see your file. We see your Google Drive.
Oh,
You need to show us. You need to share with us the file itself. Because sometimes when you click on PDF file, it opens another window.
okay. Mm,
Right, it's very late. Okay, if you guys want to leave, right, you can leave. I'll wait for him to see his presentation.
All right, thank you so much. Have a great night.
You'll come, you too. Thank you. Good night. Kaya, prepare to present. Okay, take care. Good night. Okay, good, Kyle. Good. Okay, it's up.
Is that the one just presented? No.
Yeah, you can present.
All right. So basically, in this problem, it says to find the Laplace transform the given functions of the given function. We have first of all, the first step we're gonna have to split. Turn it into partial fractions, so we can make it easier to work with. And in that case, we're gonna have f of s equal to a over 3 minus s plus b over 3 plus s. And then by doing this, we can multiply both sides by the denominator, which makes it turn into the equation we have in the second line. S minus 5 equal to a times 3, a factor 3 plus s plus b factor 3 minus s. And then we're gonna have s minus 5 3a equals to 3a plus 3b plus a minus b factor plus s factor a minus b. Then we're gonna have to match the left and the right side by analogy. In that case, we're gonna have 3a plus 3b equal to the constant minus 5, and then we're gonna have
You have to match up the coefficients.
I'm sorry.
You have to match up the coefficients of the variables. Yeah. Okay.
Yes. Let's say we're gonna have a minus b factor s, a s minus s factor s factor a minus b will be matched to s, which has a coefficient of 1, which is not showing. So we're gonna have a minus b equals to 1, and then we're gonna have 3a plus 3b equals to minus 5. Okay, and then sorry. And in that case, we can plug in back into the partial fraction we had before, which was a over 3 minus s plus b over 3 plus s. So in place of a, in place of a, we're gonna have 1 over 3. And in place of b, we're gonna have negative 4/3. Negative 4/3. So the new equation will be f of s is equal to 1/3 1 over 3 times 3 minus s minus 4 over 3 times 3 plus s. Now we can take the inverse Laplacian of our uniform equation. Uniform equation. So in the first we can take the Laplacian by linearity. You can take the Laplacian of each fraction. Then in that case, where I would where I put the asterisk, we know that we have the inverse transform of 1 over 3 minus a, which is equal to e over e power e exponent at. So which is a form of whatever we're getting right now, which is an example what we're supposed to get, the form of the new expression we're supposed to get. And then the transform, our transform will be of the form f of t is equal to negative 1/3 e exponent 3t minus 4/3 e exponent negative 3t. And number 17.
No, second.
I'm sorry.
Okay, so your final answer is this one, right?
Yeah, I'm done with this one. First one, we need to find the inverse Laplacian. Which is f of t. I'm looking right there in circle. That's a circle in red. I had something else. 16 and then 17. This is pretty short. This is the same question they asked for, and the question was to find the inverse Laplace transform of the function f of s is equal to negative 3 negative 3s. No, yeah, negative 3s power negative 1 times e to the power negative 4s. In that case, we're gonna have to use the properties of the Laplace transform to get the inverse of this function this equation.
Hold on one
And-
second. Hold on one second. So your f of s equals to negative 35.
Negative.
What's this notation? This one. That's your f of s, right?
Mm-hmm.
What is it? Negative 35. Read
No,
by what?
this.
Read by what?
These negative 3s, not.
Oh, negative 3 s reads by
Yeah, I'm sorry.
s reads by 1.
Yeah, I think I will put something extra in there because the first line of the bottom part after I would the Laplace inverse is negative 3 times e to the power negative 4s. So that's a mistake. I overwrote something. I'm sorry.
Okay. So negative 3 s reads by negative 1. E reads by negative or positive?
Okay. All right. The question is negative 3 times negative 3 times s to the power of negative 1, which can times e to the power of negative 4s. So on the second line after the equation, the Laplace inverse, I turn s negative 1 to fraction form, which is 1 over s, and then I use the first equation on top the Laplacian to find the Laplace inverse of the equation that was given, which is negative 3 times e to the power of negative 4s times 1 over s, and then after that we found that f of t should be equal to negative 3 negative 3 u subscript 4 of t is equal to negative 3 theta times t minus 4.
You finished?
Yeah, for this one.
Okay. Do you really understand the question 17?
Yeah, not fully.
So explain to me that if you think you understand the 17, explain to me. When you present a question, you need to understand what's going on.
Can I present number 12 instead? Because had to difficult to understand the function I use, the Heaviside function.
Okay. That's
Yeah, I'm
what
sorry.
I'm.
And I didn't do nothing actually. So number 12 is asking us to find the inverse or Laplace transform of 1 over s5. So the function that gives us that generates the inverse Laplace transform for this function is Laplace of n factorial over s to the
Good night.
power of 1, which is equal to t to the power of n. And now situation we have f of s is equal to 1 over s to the power of 5. So to find corresponding to match the exponent, we compare the n factorial to the n plus 1. To find the n, sorry, we had to form equation n plus 1 equal to 5, and then n is equal to 5 or into 4. Then I found I was trying to find the Laplace inverse of 4 factorial over s5, but didn't ask for 4 factorial over s5. They asked for 1 over s5. So I used the property of factoring for Laplacian. So I divided Laplacian by 1 over 4 factorial. In that case, I will get I factor out no, I divided by 1 over 4 factorial. So in that case, I got 1 over 24 times t to the power 4, which is the inverse of 1 over
Okay.
s5.
All right. Okay. All right. Keep presenting. Okay. So getting your presentation grades. All right.
I'll present number 17 next time.
Okay. Pick some good questions. Okay, to show. Okay. Anyway, do your best. All right. Have a good night. Good job. Okay. Yeah. Keep it up.
Thank you.
You're welcome. Okay, Ryan. Ryan, are you still here?
Yeah. Don't worry, I didn't fall asleep. I wanted to ask you,
Yes.
what do you think would be the best topic to present maybe on Thursday, assuming I have time?
At this moment, just
Laplace transforms?
yeah, should be
Okay.
very easy for you. Laplace
Okay.
transform, inverse transformation.
Mhm.
You know, all right, initial values.
I'll
Yeah.
try to come up with a good question.
Yeah. Okay. Counting on you, Ryan.
Okay, I'll try my best. Gotta prove myself, right?
You're A+ student. You gotta go through.
I'll
be
try my best. I'll try my best. Hopefully, when we get closer to the final, I guess when everything's wrapping up, I might because at that point, there won't be too much homework. I might make like a really big question and solve it with like 5 different methods just for fun.
Okay. All right. Have a good night.
Well, have a good night.
Okay. Bye.